Yo, 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 good morning, good morning. Okay, so it's been around a week since I last did anything with this, I think, and I'm trying to remember exactly where we left off. Unfortunately, I do remember that we didn't really finish the tessellation before I had to take a few days off. But I think there isn't really that much left, so hopefully we can pull it off today. It took me a few seconds to realize what we're seeing here, but basically we subdivide based on distance, and the color of these subquads goes between black and white, and the brighter it is, the closer it is to being subdivided once more, basically. So when it's fully white, we should bring it down one. Okay. And the idea is that, so when we're over one quad, it's fully black, then we... So for this one here, right about here, we subdivide it, and then we start to interpolate the points. So right about here, when we're in the middle of two, interpolating both of them here, that's pretty bad, I assume. Yeah, we're gonna have to adjust it a little bit. I just want to make sure. So what I want to adjust is when it happens, basically. So if we start interpolating here, if we have the camera between them and we interpolate the positions here, it's going to be extremely visible since the camera is close, right? So we probably don't want to do this unless we're at least one subquad away, I would guess. Looks to be all right. So let's take a look at, I just want to see as well. Okay. And the color we output is, we just output T here. That's the color, okay. Gonna change this one to return 0, and then I want to check, so somewhere the T we're working with, or which we outputted, that's the one we want to utilize. Here, I would say. Okay, so let's follow the full pipeline for the T. We calculate the T here. We calculate two values here. One is the floored tessellation amount for the plane, and this is the unfloored tessellation amount, and then we get the difference between them and we inverse slurp between 0 and 1. So if the difference is between 0.5 and 0.75, we we pretty much remap 0.5 to 0.75 to 0 to 1. And then we send on the T in the domain shader, we just send it on. And then in the geometry shader, this is where we're going to use it. And pretty sure we're going to use it here. Not entirely sure how I want to do with the normals. We probably want to interpolate the normals as well. We do it here. Okay, beautiful. Position. We interpolate this one. We interpolate normals. And yeah. So output T instead. Step, where do we use this one? So we're just going to remove these. This one as well. Something like that. We won't be able to see the interpolations unless we restart this. Okay, I can see some interpolation, but I can also see some seams, so it doesn't look too good. Thought I could see some interpolation. Okay, we can see the interpolation here. Yeah, we want to do... Pretty sure we want to do 1 minus P1T here. So what was it? The brighter it was, the closer it was to being subdivided once more. And yeah. Still see a lot of seams, that's not good at all. Yeah, okay, we don't handle the seams just yet. Okay. I can also see it looks a little bit weird here. So if we take a look at this one, and then we add points. It looks like the points are offsetted a little bit wrongly. Yeah, we can see we get this jagged edge, which we shouldn't get. Okay. Then as we get closer, we start interpolating them more. Making it smoother. Okay. Okay, I get it. some of these points we create. Let's take a look at this one again. So if we take this triangle and we subdivide it, first of all we create so this point and this point and this point are all new points, and so initially we give this point a height that is interpolated between 0, and 01. We do the same with this one, but 01 and 02, this one, but 0, and 02. But then we also add these points. I wonder if their interpolation, so this one for instance we interpolate between S12 and 02. It should be okay. Okay, the problem might be... It shouldn't be. We create these first, and these should be interpolated right. Create point from. Actually, I'm thinking, is this wrong doing 1 minus here? Yeah, it probably is. The brighter it is, the closer it is to being subdivided once more. We want it to be close to position final VS then. So what was the problem with this? If we move closer to this one... Okay, it's definitely, if we move closer to this one, 1 minus, because we should be seeing the interpolation the other way. Order what up? It should be no interpolation in edges to avoid this effect. We're gonna fix the edges eventually. I just want to fix... we're gonna interpolate the edges as well, eventually. Well, I wonder... Yeah, we're interpolating the wrong way here. I wonder with this system as well, we're gonna have to pre-calculate the height maps, I think. The MIPS of the height maps, we're gonna have to force more control over them. So we get an instant like this, but if we move further away, yeah, we interpolate the wrong way. Let me take a look at this. So, in the hull patch constant function, we calculate our T. It's 0 if... Yeah, it's 0 if we should have the final position. The brighter it is, oh, one sec, let's take a look at... Yeah, we want to fix one thing with our... So, sorry about that. If it's black, we should have it... if it's black, it should be at its final position. If it's white, we want to have the interpolated positions. And then the closer to black it gets, more towards its final position. So white we just interpolate, and then when we get closer we do the final position. But yeah, so one minus, so if it's white we want position interpolated vs, if it's black we want position final. So this was the correct choice. Although I wonder... Oh, do we really? Okay, that explains it. P1T. Just take a look at this. Yeah, we want to do some additional calculations here later on, but E1T. New point we don't use yet. Right about here. I'm still questioning this pattern we're seeing here. Yeah, we do 1 minus here, so let's do... Wait, let's do this actually. We should be doing that one way earlier, so let's do it here. It's more like it. And then we only want to do it for the new points. That's when the new point flag and here we fix the seams. Let's take a look. So with this 1 minus change, it's gonna mean if it's black, we do interpolated value. If it's white, we do the final value. And then interpolate between. So S01, it's a new point if it's seam. Okay, so I wonder if we just want to do new point times this. And then we go like this. So yeah, this is not good. Did I say white? Actually, we want to do it like this. Worried about these right here, but new point times might not be the correct thing to do. S12, that's this one. It's not a new point. Take this. This one is a new point, so we have a value of 1 for that one. Do we want to see here? float t is equal to something. I'm going to set new point p1.t here for now. So the interpolation here, we just want to do this for new points all the time. Yo, what's up, PG King? Gene, what's your last video, the Tessellation shenanigans? We're still doing Tessellation shenanigans here. It's like we're right at the end of it. I can taste the victory. Hopefully we'll be able to finish it today. Okay, so the T we send down, I need to keep track of everything that happens here, but the T we send down, the P1.T or P2.T, it's the same T. It tells us how close we are to subdivide, basically, once more. And we want to interpolate based on this one. But we only want to do interpolation if it's a new point. So it's basically if new point is bigger than 0.5, p1.t, otherwise 1.0. Something like this, pretty much. We can probably manage it without a branch eventually. Okay, this looks better. So right about here we do no interpolation, we just have the original position. Then when we slowly move here, we can see that some points turn black. The idea then is the darker they get, the more towards position interpolated they are. But that's not entirely true for all the points we see here. So for these, like, we have to manage. So we can see here that this one is black, so it will probably it's the white ones we remove. And we can see here that it's not entirely correct. So since this point is black, it's fully interpolated. I would like it's these points. We would like to be black. These should still be white. So at this point, all the points that disappear here should be black. So we can see here that it's the wrong points that are marked, but also a few too many here. Actually, it makes me wonder if did I fail on this simple? If it's a new point, Hmm. Okay, we have a problem that we're not calculating the T for these ones as well. So it would look like... Okay, so what do we have now? White are new points. Black are old points. But we don't get... These are still not handled correctly. So this one is a new point right about here. Maybe. I'm looking at this one. It's marked as a new point here. It's not marked as a new point here, but this one marked as a new point, still marked as a new point. Wonder about the seams here. How much this will screw us. Like this one right here, it's a new point at this point, but here it's also a new point, which means that we will get interpolation there twice. We're gonna have to double check the seams. So if it's a seam here, we don't want to mark it. But apart from that, I just want to double check. I feel like we have something wrong with the heights as well. So everything is marked accordingly now, but height still looks a little bit weird, doesn't it? Do we actually... Don't we have any seams right now? No, we don't. Okay. Yeah, we can see that the heights are a little bit off. So when we when we subdivide this once more, we want it to have the exact same silhouette, which it doesn't. And then when we get closer, we animate them accordingly. Right now we can see that we animate them, but the initial is wrong. So this one... Nice seeing the seams work at least. So right about here we should add a lot of extra topology. We shouldn't... change the topology. Oh, I see a seam here that doesn't work, but that might be... yeah. I want to see what happens if we bring down... oh, we don't even tessellate the maximum amount. But if we bring it down to about here... and look at this weird heights we get here. So this one, look at this one. It goes up to here initially. And then when we move closer, it tessellates towards its end position. Yeah, the initial positions are fucked. I don't know what is happening here. And then it goes back up. This is a new point here, but not here, so it should be at 1. Yeah. I find this extremely weird. This point right here seems to be interpolated correctly. This one. I don't know about these ones. So this point right here, this one, this one behaves exactly like I would want all the points to behave. So if we move closer here, we're going to see a new point spawn here, but the topology or the silhouette doesn't change because it's entirely interpolation based. So the new point's position here is based on this point and this point. So we can see that right here. That's very good. And then when we get closer to it, it fades into its correct position, right? It goes up. So why does that one behave the correct way, but we have problems with so many other points? This one moves, this one doesn't. Moves here. Okay. Yeah. I'm gonna have to analyze these values. Okay, output T is new point. So this and this. Let's get this one right first of all. So it's 1 if it's a new point. In this tessellation, it's black if it's not a new point. Should be easy enough. This one is black, so if we zoom out, or actually if we move, okay, so here it turns white, here it's black, so that's good. And this one is white, yeah, because it's new. If we take a look at the edge points, this one is black, it's not new. All true. It's not new here either, okay. This one new, yes. This one not new, that's true. I mean, that seems to be working. This variable seems to be correct at least. I'm just gonna grab a cup of coffee, 1 sec. The question is, Veronica Hacks, what's up, what's up? Is something wrong with this variable? Can we find a case where this variable plots the wrong thing? I think that would be, so this one is white here, this is a new point. And it's black here, that's beautiful. That's what we want. This one is black, still black. We don't have any points here, here. This one honestly feels like it's spot on, I would say. Right? Okay. So we have T, which is 0 for old point, 1.0 for new point. Right. I'm a little worried about, so it's a new point, this one is a new point here. And it's also marked as a new point here. That's not good. Okay. So the problem we have, should it be marked as a new point here? So it's thanks to the seam we have implemented. Right. So we add this one here, it gets marked as a new point. We want to interpolate it. Yeah, so this one, with the current position, all the white and black points for this one are fully at their final form, so to speak. That should hold true here for white as well. But when we move to here and start interpolating, we start interpolating these points again. Yeah, we need to add a fix here. So in this case, we don't want to mark this one as new. Right? I wonder if this is going to be a bit complicated. So the white ones here are fully interpolated, and then when we move here, yeah, this is going to be interpolated again, and that's what we don't want. So this one should be at its final position right about here. And then we move to here. Now we have subdivided once more. This one is still white, so it's going to be interpolated position. Okay. So previously we have always checked. So for this subquad, if this one has a neighbor that is subdivided more times, then we fix these. So the less subdivided has always made the extra checks. Here we're gonna have to check if we're gonna have to add a check that checks if the neighbor is subdivided. Oh, this sucks. So the interesting part are We don't have this, so we don't do this. We just do this, but we want to mark... Yeah, so we're gonna have to add some extra logic here. The logic we want to add is... We don't... It's not a seam anymore. It's not a... I wonder if... So right now these vertices here are marked as seams because we're going from subdivision x-1 to subdivision x. But right about here, these are not marked as seams anymore. We don't have any temporal information. And it is, but... Okay, we don't have to fix anything. Or do we? One sec. Two. Check we need to do here is the straightforward way to do it would add too much computations, I think. We're gonna have to add a check for every point. Hit this. But it's all tied to the fact, let's see here. I wonder if it's tied to how we do the subdivision right now. We're pretty conservative. So pretty much when we're half a subquad away from this one, that's when we change it and start interpolating it. I think it's a bit too late, honestly. So I wonder if I want to fix that first, because imagine running with the camera right about here. We run towards this subquad, and when we're here we can start seeing the subquad change. It's way too early, or way too late. Wonder if the logic still holds. We like, if we can implement the logic for this case, it should work for the one we extend. But we could make it easier for us. So if we just start, if we don't care about when the camera is between, we just care about the middle points. So this one doesn't flip here. So this one is subdivided as many times as this one. This one is subdivided once less. I'm gonna have to draw this, but yeah, maybe that would be easier. But how would that look? Yeah, we're still gonna have to mark the points accordingly. But basically what we have now is basically we truncate the camera to each of these points. What I want to do is I want to truncate them to only these center points. And then we do all of the squares around here are subdivided as many times as this one. And then here we still truncate it to this point. It's when we get to this point, when we truncate it to this point. So as we move, this square, is this weird? I don't want to flip in subdivision at this point, but rather here. Just wonder how that would look. So this one fully... I want this to play out. Fully tessellated. Right about here it should be. Yeah, I think... So if we only truncate the camera to these points. Right now all of these within the outer square is fully subdivided. And then when we move about here, so then... How would that work? Yeah, so when we move here, we start... This one, we start to interpolate backwards, or towards the interpolated values. For this one, we start to interpolate towards the final values. And then when we get about here, we flip, so we get truncated to here. So right at this point, or if we're over here, all of these 9 are fully tessellated. These 1 are tessellated, 1 less. We still have the problem with the... Still extremely weird. Like we would see this interpolation too much, I reckon. Let's see here. I think it's good. So this one has the same subdivision, it's also fully interpolated. So it's when we're further away than one sub-squad, that's when we start interpolating it. Does that make sense? So if it's... We truncate the camera to the full points. We subdivide max for all of these. If the center point is 1 or less subquad away, it's fully implemented or fully at its final point, final value. So it has a t value of 1. So when we move closer to this one still has a t value of 1, but this one starts to decrease. Is it too early? We would subdivide this one at this point. Yeah, I'm gonna have to implement this in such a way that we have a lot of parameters that decides this. So we can experiment a lot, because this is gonna be highly dependent on the final terrain resolution we decide upon. So number of vertices per world space meter. Yes, I really don't want to care about this right now, do I? Like, even if we would change to this, we would still have the same problem with the points that are marked as new, even though they aren't new. But we pretty much just want to mark points as seams, which I think we do. We're gonna do a double check. And if they are a seam towards something that is... If they are a seam towards the camera, so not far away from. So if we take a point here, how does that work? If they are a seam, and Or do we have seam? Yes. We just check. Does the subquad neighboring to this edge, is it tessellated more times? If so, we have a seam. Probably want to send in... Probably want to be more precise here. But... Oh. If it's not a seam... If it's not a seam, these points are never new points, right? At this point, so this point right here, it's new now for this subquad, but not for this one. And we move to here. Now we don't have a seam here, so this one should be marked as not a new point. It's gonna be marked as a new point when we get to this one. Okay. Yeah, so it should be as easy as... But if this one is marked as a new point here, but not here... Not a new point, not a new point. Okay. Yeah, so then we're gonna have... This one is gonna be marked as a new point, but on this side it's not gonna be marked as a new point. Does that make sense? No, it's not. Yeah, we're gonna have to send down that information somehow. So instead of sending it down like a boolean, we can send it down like a signed sign. So if it's 0, 0, if it's 0, it's the same subdivision. So if we take the perspective from this sub quad, this edge right here, it's 1 right now because it goes from tessellation x minus 1 to x. Here it's 0, and now it's minus 1 then. So 1, 0, minus 1. If it's If it's 0, we mark these as not new. If it's 1, we mark them as new. How would that look? So many things to keep track of here. So here it would be -1. Then we want to mark them as new. Here we don't mark them as new. Here we mark them as new. Thinking, is it just at this point we don't want to mark them as So at this point, the closer we get to this one, I want to interpolate these. We want to do the same here. Here we don't want to interpolate them. And then right about here we want to start interpolating these. Do we want to mark these as seams? I'm wondering if we want to change this one to not equal to tessellation exponent. How would that look if we just changed this one to this and let everything else be the same? So at this point, what do we have? Yeah, this one is new here, it's not new here. It's a bit weird. It's wrong. Something like that. We would need to do something of that sort. I wonder if we can probably do it like this. Let's see. Gonna do seam. If it's greater than it's true. So if we do minus, 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 then we do beautiful. We do it like this, and then if we, in the domain shader, if we just call it seam here. If we were to do bigger than 0 here, we would have the exact same result, right? Okay, beautiful. But now we have some more information we send onwards. Let's see how we handle seam. We don't do anything with seam. We do it here, here, here. And then do we use seam here? We just set seam is equal to... Okay. So we could probably do... The only thing we care about are these ones, I think. But we don't even need to do bigger than 1 here, right? It should still work exactly the same. Okay, good. So if we then do... new point here. What points is it that we care about? We care about... It's never gonna be the diagonal one, so never any of S1201, S12, so none of these. We care about... Is it these ones? No, it's not these ones. But it's S20 and S01, I'm pretty sure. If we take a look at this one, it's marked as new here. And still new here. So it's S01 and S20. This one and this one. And right now we do this. Oh. If both of these are edges or seams with a 1 minus, does this work with the... So it's 0. So basically, shouldn't this fix one? If 00 and 01, if both of these are marked as seam, previously that was 1 greater than 1, then we marked this one as a new point. No, not a new point. Yeah, that's true. Because then we do this one. We still want this one to be true, but if this one is -1, don't do anything. Okay. If this one is 0 here, we get... We want to do some other check here. We want to do... If... S1 and S2, when do we want it marked as a new point, and when don't we want it marked as a new point? Oh, okay. We have to take into account these points that are in the middle of the square. They should have a seam value of... Fuck, that's a good point. Yo, what's up, Spyos? Thank you for the raid, appreciate it. You too. Enjoy that lunch. Over on this stream, we're still fighting with Tessellation. Unfortunately, I pretty much had no time to work on it last week, but we're pretty much at the end of it. Just trying to get that last piece of the puzzle in place. But it turned out to be a real headache. These seam vertices. When to interpolate in them, when to not. With the current setup, so previously we sent down a binary value if it was a seam or not, but it had to be a seam on the correct. So going from one subquad to one that was subdivided less, that didn't count as a seam. This time around we want to change that. But so if we move away from a binary value, we're gonna have to take these into account once again, and that sucks. Or actually, we might not. So these ones in here are always... No, they are not. It's not this one we have to take into account, it's this one. I wonder if we want to do... basically a new point. Look at this point. So right here we want to interpolate this one. We also want to interpolate this one. That is true. Now I'm starting to think that, let's see here. Ooh. Okay, I think I might know a better way to do this. So, marking them as new points or old points like we do right here, it might be the correct way. But then we want to interpolate the t. We might not want to calculate the t. Let's see, how would that look? If we do... For each point here, for each new point, we calculate the distance to the camera, the floating camera. So not the truncated one. And then we interpolate it based on that. I wonder though... So these points right here would have a value of 0.5 going towards 1. Yeah, okay. No. Still flipping the full one here. Could we do a bit more dynamic? It's this full subquad flip that sucks. Okay, so here for both subquads we want to mark this one as new. Here for both subquads we want to mark it as old. Here for both subquads we want to mark it as new. So it's pretty much when the direction is 0 we don't want to do anything. Okay. But mark it as new if doesn't work for the ones on the inside. Okay. Yeah, we actually had it as this previously. Okay. With the current setup, we send down -101. Sucks for the middle points though. Problem is that we need these to be still pretty sure we can create this in an easier way, streamlined way. So the problem as I see it is we set the seam flag, or it's pretty much a flag now as well, but multiple different values. We set it in the hull shader patch constant function, or hull patch constant function. And then we interpolate it here. We just check if it's still true. That, yes, okay. We do lerp here. We could still check if it's an integer. So we have it as -1, 1, 0, but the lerp might result in a integer value. It's not what we want to do. It's basically like this. We want to pack. I want to be able to represent the points as, is the point a seam or not, i.e. is the point at an edge or not? If it is, what type of seam is it? So it's pretty much two values. So we might as well do seam direction and seam, pretty much. Okay, let's see if we can get this in place. Seam direction. This one is gonna be, that's gonna be a lot of values. Can we go that high? That's not what I want. Semantics. Text chord N. And it's an optional input and a number sources supported. Now 10, that's quite a lot. But then we could do this. Load 2. So we can do sine. Yeah, the problem is when we do interpolation. Actually, we can just send it down like this. Seam XY. Okay, let's do it like this. From this one, all we care about is the direction. And then here we do float 2. So when we calculate the seam here, we don't want to do max here. Wonder if we want to do... pretty much what I want to do here is... I think we can do it like this. Output seam is equal to float 2. One sec. I want to keep the direction value. Do bilinear interpolation with vertices on this edge and this. They have edge values. Like, we don't want to do bilinear interpolation between 4 corner values. Or actually, do we? Yeah, maybe we do. Yeah, let's do it. Why not? So, hey, what's up, Matt Birds? What you working on? We're right now we're working on like a custom tessellation solution that is going to be used for the ground and water and snow and whatnot. But from a broader perspective, we're working on a creature collecting game similar to Viva Pinata, I would say. It's a very weird interpolation here, because basically we have 4 edges on each side. We want to calculate, I guess we want to take the edge direction, which one we're closest to, but then we're gonna have to figure out so if we have a point here, we would like it to be E0. The middle point, I don't really know how to handle. We could do it with a branch. Maybe branching is best. Basically, we mark the edges as seams, and we just want to convey this information down to the geometry shader in a usable way. Which would be... I mean, the easiest way to do it would probably be if... I don't like that one. I want to remove this as well. When we just wanted to mark the seam as if it was a seam or not, it was binary, it was pretty straightforward. Max works, lerp works. But we need this, we need this. Okay, what I'm getting at is that we could do something. It's not that nice. We could solve it like this, but I want to avoid this. So if uv tessellation.x is equal to 0.0, we have done something similar in the past. But we have one thing. Ooh, I wonder how we handled that previously. That is true. So how do we handle seam points like this? We could have a seam both here and here, so that's 2 directions. And that screws with our solution. We want to do something special in this direction, something special in this direction. Original vertices, though, I don't really care about those. Original vertices we always set at 0. So I think we could do, yeah, let's try this. We have it here. Yeah, if uv tessellation or x is equal to 0.0, else if uv tessellation dot y or dot x is equal to 1.0, else if uv tessellation dot y 0.0. Something like this, and then we do output dot seam is equal to float 2. So x is going to be binary, yes or no. Y is going to be direction. So if x is 0, we do E0. So then we do 1.0 factors dot seam 0. It's 1, it's 2, 1 and 3. Now we just need to handle this seam a little bit differently down here. if we want the exact same result as previously, we can do dot. We can do dot x here. And then what did we do? Yeah, here we just do dot x. Pretty sure. Oh yeah. Yeah, we can see here that we want to refine this a bit. We don't just want to make 1.0. We want to do the checks we did here. We need to improve upon them a bit. Which makes me wonder. Which makes me wonder if a better solution would be to and we can explore that one later on as well. If a better solution is to not add vertices for the one going from subdivision x-1 to x, but instead remove from the one that is higher subdivision. Why didn't we do that, by the way? Wow, that would have been much easier, wouldn't it? Here, instead of adding these right here, what if we just removed oh yeah, the reason we didn't do that is because we will get some weird long triangles. Yeah, maybe it wouldn't be pretty. It depends. Maybe it would have been a better option, but that would leave us with so this triangle, for instance. We remove these three and do okay. Okay, so if we want to make the previous solution work with this new data we send in, we're gonna have to add an additional check here, which would be that's a lot of checks though. So we check if this is true, and then we check if both are basically look like this. Not a big fan, but let's see what we have. .y, if that one is bigger than 0, I think. Something like this, and then we still have this one. Do we calculate this one? 02 and 01. No, we don't. Or 00. That's the exact same result we had previously. Not exactly. We get this right about here. Yeah, we don't get this line right here. Because this point... the direction here... yeah, we have the same issue here. We do care about these points. Direction. So this one has... it's an edge point towards two directions. So we're a little bit fucked. Yeah, we actually have this as well. Right here. Although I am a little surprised that... T, what's up? If I'm just starting to learn code, can Rosebud AI create a game for me without learning to code? I have no idea. Honestly. I haven't dabbled that much in AI, but from what I've read and such, you can probably make 80% of a game. Yo, what's up, GDs? What coding book would you recommend for dummies? I haven't read a book in a while. Like, depends on what you want to build. And when you have decided what you want to build, I would just Google the internet for some resources. There exist a lot of great resources online. I don't really think you need books these days. Video King 80% sounds about right, and fine-tuning it is going to be a pain. Yeah. You can probably get a very good presentable prototype in place. I think it's going to be a pain, but it's doable. But then, like, making it into a nice product is going to be hard. A video game like Street Fighter. Yeah, I would choose a game engine first and foremost, and then I would just Google like Street Fighter like prototypes for that game engine. Wouldn't be too surprised if there exists a nice tutorial or introduction right up online. I mean, when I started game deving, I had some programming experience previous to that, but still, I wanted to do a tower defense. And you can imagine, like, there exists a lot of tutorials on how to do a tower defense in Unity. Pretty damn helpful. No problem at all. I don't know if it was that much help, but good luck, good luck. Okay, so back to this tessellation hellhole. Like, I thought getting the seams to work would be easier this time around. We've done it previously with some bad topology. Now we want to do it with good topology. We want to mark the seams. We want to mark the seams as let's see, I don't think we care about... We can probably mark them like this. Let's see here. 1, 1, 1, 1, 1. And here we do if seam is bigger than or equal to 0. That's pretty much all we care about, I think. I think all we care about is this. That's not entirely true, though. I wonder if we want to care about more things down the line, but we want to see if it's an edge, and if it's an edge, we don't care about direction. But we're still gonna have a UV tessellation where we're gonna have a coordinate that is 0, 0, and it's very important that we give it the correct value, right? Can we manage this without... Okay, the only thing we care about is... If we want to make this solution work, the only thing we care about is... Is it an edge? And that we have managed to... We have managed that by simply doing this branching here at the moment. But actually now when I think about it, might be doing it in a... If we mark the original vertices as edges, because they are, that's pretty much what we're doing. Okay, what about this? We mark them. We give them a flag value pretty much. If we move towards a neighboring subquad that is tessellated less, we give it 1, a value of 1. But only if it's an edge. I've painted myself into a corner at the moment with this solution. I don't like it. Edge, 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 edge. But one sec. I'm starting to think that I might have change here. Okay. I'm starting to think okay, so the problem we have is at this point for both subquads it's marked as a new point, right? It's marked as a new point here as well. It's marked as a new point for 2 iterations when it should only be 1. But we have a t value we can use here. We have a t value right, new point, not here. We have this t value. We can probably change this one to if we activate the edge points earlier by doing 0.25 to 0.75 here. Let's do this. Where do we use t later on? Output t. Here we just send it onwards. 1 minus. Here we use t later on. T is equal to 0. Let's do this. Okay, this I think might. So float 2, and we're gonna do we are gonna do interpolation. It's a float 2 currently. So where do we have t? We have t here. And what I want to do is float plot interpolation, float actually we're gonna call it diff, and then we do output dot interpolation is equal to float 2 this is going to be our interpolation x for u for s and 0.25 0.50 this is going to be our t, something like this. So now we have interpolation instead of t. We just use it here currently. So for now I'm going to do t is equal to p1 dot interpolation dot do s, right? Or let's do u. So p1 dot interpolation u yeah, here I want to do factors t. We're just going to do output interpolation is equal to factors dot interpolation, and here we're going to do 1.0 minus whatever result we get from this one. Invalid subscript u. Load 2 interpolation, load 2 interpolation. Yeah. Invalid subscript T. Oh, yeah. So we should be able to do interpolation. We don't want to do .u here. Turn input interpolation dot x. Okay. Yo, what's up, Bush? Good morning, good morning. It's around midday here. Glad to see you back on the grind. Appreciate it. Okay, so what we're seeing here is... Worry about these. P1 interpolation X. What am I missing here? Factors interpolation. Should be the same interpolation for the full quad, so these black points here doesn't make too much sense for me at the moment. Why are we getting those? This works. We're getting black here, not here. Okay. That's weird. Yeah, okay. We want to wait with this one for a bit. Okay, so one fully interpolated, 0. At 0 we do no interpolation. Oh no. At black we do fully interpolation. At white we have the final points. So we can see here that we have a little bit of a problem because this one, so the seam here, all of these are at 1. i.e. they should be fully interpolated, at their final point, I mean. But then when we jump over to here, we get fully interpolated for this one. But we want these points to be at their final points because they existed previously. So what we can do now, hopefully, I can also show P1 interpolation. We do .x, so I want to do interpolation is equal to float 2 new point 0.0. We have this to our help as well. So new point. This one at this point. That's weird. New point. Yeah. Seam. The new point is not correct at the moment. Wonder if it's only this one though. Actually we need, so back with this one right now, we do 0, 0. There we go. Okay. So here we have the problem. This one is marked as a new point. When we get here, it's still marked as a new point, although it shouldn't be. We need to sync the color of this one for this subquad and the color of this one for this subquad. And we know that they are seam points, and I'm wondering if we can use... interpolation, p1.interpolation.y for this, together with seam then of course. Here that this one yeah, we can probably use it. Maybe this is gonna be a little bit of a problem. Is it? under. Makes no sense. You know what? Let's do it like this. Seam. Float 2. Yeah, float 2, and then we do... We're gonna clean this up later on, but we do... This is our X. And then we have our Y, and the only thing we check here is if they are the same. Yes. Do we send on seam here? Seam, yes we do. Float 2. So then in the main shader we do seam.x .x. Y, and then we send it onwards. We have float 2 there, so seam float 2, seam float 2, yes. And then down here we just do, so wherever we use seam here, that's our old one, so we do seam X. Then I wonder, do we use seam here? We do it like this, so output seam dot X. So we do it like this, and then we send onwards seam X, yeah. So let's try input seam.x. Okay, that's beautiful. Think we care about this one? No, we don't. And then we try, let's see here, I want to see what seam Y looks like. Seam X, seam Y. Okay, not exactly what I want. So let's take a look at this one. This is what I want. So why do we get this one as full white? It's beautiful. This is not. Why if it's same. Okay. And this should be okay.
The easiest way to get into the meditative state is to begin by listening.
So for this one it's true, for this one it's true. Here it's true. Okay. X. Yeah, we get 1, 1. And we're gonna take the maximum. Yes, we get 1 for all of these. That's not good. What can we do about that? We can... So it's this one. So if we have this type of seam on both sides, we're gonna get 1 here over the whole sub quad. That's not really what we want. But Thought we could rescue it down here, but I don't think we can. We do min Tessellation X. We go between this one and this one. If we're here, we get this value. 1 1 min. Nah. Going full mental here. You serious? Yeah, we still don't want to do this. That's true. Fuck it, I just want to make this work now. So then we're gonna get the same problem with the corners. Then again. Maybe we can still use it, even though it's not 100% accurate. Let's do it like this. If theme.y is equal to 0.0, and then we do we have edge 0, right, 1, 3, something like that. But I want to do max theme.y. Do I care about this one not being white here? No. Okay, now we have what we want. It looks like shit. Like we want to improve the code a bit eventually. Okay, so the idea now when we have this value is so we have something that tells us if it's a new point. We have a lot of different variables now, finding different things. Output seam y. So basically what I want to do is that when we have something like this, I want to take when we have something like this, none of these points are new. Is that really what we want to do? Yeah, we have already interpolated them in a previous. So all of these points, we interpolate them here, and when we get to here, they are not new. Okay. I want to rename interpolation here. I think it's interpolation. Let's go back to T. Let's make it into a float. Output T is equal to this one. That, and then we have interpolation here. T. Output T is equal to something. Let's just do p1.t. Do we have any errors? Yes, we do. Yeah. T1.t. And then we do return input.t here. So then we have this. So this one explains, or this one visualizes the interpolation we want to do. One is full final point, black is total interpolation for the new points. So the idea here is that when we get to about here, the line points here will still be white. And we should be able to visualize that by doing so output t, p1t, and we can do it like this, p1.seam.y, begin at 0.5, and we do 1.0, otherwise p1t. Almost. Fuck. Huh. Yes. We don't really want to do it like this. We want to new point when we send in new point here. Instead, we want to do. I wonder if we can do new point plus p1t. Saturate. New point, and we always say new point. These are always new points. It's these ones we're gonna have to fix. Although I'm a little bit worried about this one right here. Okay, let's do it with a new point like this for now, and then we do this, and for these we change this one to Hmm. Now we're gonna do it like this. In here we're gonna do, we don't do new point here, we do p1 dot seam dot, we actually have it, so we do output dot seam dot y plus this one. But we want to do it for these points as well. Other than that, it looks good, right? This is a new point here, fully interpolated. Here we have it as well, it's fully interpolated, and then we interpolate the rest of them. And then we start removing these or bringing them back to their interpolated values. Now when we get about here, we change to white. These are still fully interpolated. I think this looks, except for these points then of course, but that's just we set this one to T. Yeah, I don't think we want to interpolate those at all. Actually, we want to do it like this. We want to add new point as well. So if it's a new point, we want to do this interpolation, otherwise we don't. So new point is 1 if it's a new point. So I want this one to be 1 if it's an old, let's just do it like this for now. New point is equal to or bigger than 0.5. Then we do this, otherwise 1.0. That's not really what I want to see. New point. Not a new point. New point, new point. I want the opposite here, right? Yeah, we do. Is this one white as well, though? So let's just return new point for now, see what we have. Oh, yeah. Actually, why we're getting this fade here. New point. Input T. We either send in 1 or 0, but we're still getting a fade, right? It's a little bit weird. Oh, that's true, we're doing T. Okay. So if new point is bigger than 0.5, then we do this saturation, otherwise we leave it at 1. So we could do it here as well, but this is very weird. Let's set this at 0. Or 1. This looks pretty good. This one shouldn't be black still, though. Or Ooh. This one is rough. One gets changed to black here. Is that what we want to do? These should still be white, I reckon. That's because opposing Y plus P1T. We want to do E1T. I don't get why. Okay, this fading is nice. We move on to fully. Like, I don't know why these ones are black in this case. Because we have those points in the next iteration. Then I hate this as well. Getting a sudden removal here. Okay, but that one I understand. Here we have an edge, here we don't. Okay, so we're gonna have to adjust that one a bit. But still, this one bothers me the most. So at this point, what I would like to see is black, white. Okay, we know that. Okay, P1.T. Yeah. Do we really just do P1T? Yeah, and then we put these. Output.T is equal to new point. And this one is currently wrong. It's wrong here as well. What did I screw up? These are always new points. So yeah, okay, so we want to change this one to okay, there we go. So new point is true. We can trust new point. Then we want to use new point together with with the seam we have. So for instance, to remove these here. Should be able to do that, right? Shouldn't be too hard. So let's just focus on creating a new point. So the first thing I want to do up here is might want to rename that one later on, but let's do float a is equal to new point, and then we set a here. Times 1 minus, and I'm just gonna pull this one here. So if both of these are true, i.e. we are at a seam where the two subquads are tessellated the same amount, then it's not a new point anymore. So then this one is 1, 1 minus is 0, we multiply with new point, yeah. A little bit worried about this. But let's focus on this one right here first. This one right here is a new point at the moment, and here it becomes not a new point anymore. Is this pattern correct? I think so. Is this not a new point here? No, it's not. This one is a new point. These three are... Fucking hell, these three are... Or actually, this one is not a new point. This one right here. But I think it's actually a new point here. I have one extra thing we need to take into account. Here it seems to work at least. So in this very simple case. I'm a little bit worried about this one. I wonder if we can do anything about it. So that is when we move... Yeah, when we change two of these at the same time. And we get 1 point here, which... But then again, this is a problem related to us truncating at the middle points. Yeah, I'm gonna have to think this one through. Unfortunately, I have to run now. Well, I would love to continue with this one. I would really like to close the book on this one. But I'm pretty sure we will do it this week. Yeah, we'll continue this tomorrow. If I'm still sane. Thank you so much for watching, everybody. Appreciate it, and have a great rest of the day. Peace.